Good morning, students. Today we are going to start integrals. Derivatives and integration are two main components of calculus. We have already done differential calculus, that is limit, continuity, differentiability, derivatives, and application of derivatives. So today we are going to start integrals. What was the need of derivative? Let us discuss briefly. Suppose we have a circle, then it was very easy that we can define its tangent. The tangent to this curve is defined as a line meeting it at exactly one point. But this definition of tangent was not true for general cases. Suppose we have this curve, then the idea that a line which meet the curve only at one point is tangent was not true for these type of curves. So there was a need to define the tangent for general curves. So for defining the tangent to the general curve y is equal to fx, the process of differentiation was invented. So derivative gave us the tool to find the slope of the tangent at any point xy. With the help of derivative, we could draw the tangent to the given curve y is equal to fx at the point x comma y if that was differentiable, if that function was differentiable at that point. Without derivative, it was not possible to define the tangent of the curve of these points because this definition was limited only for circle. Suppose we have this curve and this is a line meeting the curve only at one point, still it was not a tangent. So to find the tangent, to define the tangent, derivative was discovered. So main aim of derivative was to define the tangent and to find the slope of the tangent. Then there were many application of derivatives, finding the rate of change of quantities, etc. So the derivative had wide application. So after derivatives, we will discuss integration. The main motivation to discuss the integration or to develop the integration was that we need to find the area of the curve, area under the given curve, because without integration it is possible to find the area only in limited case for well defined figure. Suppose we want to find the area under this curve, then without integration there is no tool. Suppose we want to find area under the curve between x equal to a and x equal to b, this area, then without integration we don't have any tool. And if the derivative of a function is given, to find that function also integration is needed. So let us discuss the process of integration, what is integration and how to find the integration. Let f be a differentiable function, in interval I, and suppose f dash is given at each point of interval I. Then a natural question is, then a natural question is, can we find functions f the function f which gives us derivative f dash is known as is known as antiderivative or integral of f dash. Now the question is, will be will there be only one f which will gives us derivative f dash, or it will be more than one? The formula that gives all the functions f whose derivative is f dash is known as indefinite integral, and the process of finding f is known as integration. So let us discuss these concepts in detail. So we'll discuss integration as an inverse process of differentiation. So let us consider this d by dx of sin x is cos x. Now, to our mind, there is a question: what are all those functions whose derivative is cos x? D by dx of sin x is cos x. D by dx of sin x plus 1 is also cos x. D by dx of sin x plus any constant is cos x. So, what is that function whose derivative is cos x? Suppose we ask somebody a question: what are all those functions whose derivative is cos x? That function is not only sin x, it is sin x plus 1, sin x plus 2, sin x plus pi, sin x plus c. So what are all those functions whose derivative is cos x? That function is sin x plus c, where c is constant. And we'll write that integral of cos x with respect to x. Integral of cos x with respect to x means, to find the integration of cos x, what we have to do? We have to find the functions whose derivative is cos x. Cos x का इंटीग्रल निकालने का मतलब है find all those functions whose derivative is cos x. Cos x किसका derivative है? Not only of sin x, but it is derivative of sin x plus any constant. Here c is known as constant of integration. Constant of integration. We can have another example: d by dx of x cube is 3x square. So integral of 3x square with respect to x will mean all those functions whose derivative is 3x square. It is not only x cube, because d by dx of x cube is 3x square, then d by dx of any x cube plus any constant will also give me 3x square. So all those function whose derivative is 3x square. 3x square के इंटीग्रेशन निकालने का मीनिंग क्या है? मुझे वो सारे फंक्शन फाइंड करने हैं जिनका डेरिवेटिव 3x स्क्वायर है. 3x स्क्वायर के इंटीग्रेशन का क्या मीनिंग है? I have to find all those function whose derivative is 3x square, and that function is not only x cube but x cube plus any constant. Now let us discuss what is their geometrical meaning. The graph of x cube will be like this. So graph of x cube plus 1 will be like this. This is x cube plus 1. This is x cube. This is, say, minus 1. So y is equal to x cube minus 1. So these will represent, you can say, family of parallel curves. इनकी यहाँ पे टेंजेंट ड्रॉ करेंगे, you will have parallel tangents. Now, based upon the derivatives, we'll write the integration. So here I am writing derivatives. Here I will write integration. So on the basis of non-derivatives, we'll write integration of few functions. So we know that d by dx of x की power n plus 1 upon n plus 1, you can differentiate it, n plus 1 बाहर आ जाएगा, x की power n upon n plus 1, तो you will get x की power n, of course provided n is not minus 1. तो suppose we have to find x की power n का integral. Integral of x की power n means that function whose derivative is xn. x की पावर n का इंटीग्रेशन का मतलब है x की पावर n किसका डेरिवेटिव है, यहाँ से आप देख पा रहे हैं, इट इज डेरिवेटिव ऑफ x की पावर n प्लस 1 अपॉन n प्लस 1 प्लस c. सो if derivative of this is x की पावर n, then derivative of this plus c is also x की पावर n. तो x की पावर n का इंटीग्रल विद रिस्पेक्ट टू x इज x की पावर n प्लस 1 अपॉन n प्लस 1. नंबर 2, d by dx इसी का पार्ट है, d by dx of x is 1. So 1 dx, or simply you can avoid writing 1. 1 is derivative of what function? X. And not only of x, it is derivative of x plus c. So integral of 1 with respect to x is x plus c, क्योंकि 1 x का डेरिवेटिव है, केवल x का नहीं, x plus any constant. Then d by dx of sin x is cos x. d by dx of sin x is cos x. So if we write integral of cos x, it will mean that function whose derivative is cos x. Cos x का इंटीग्रेशन का मतलब वो फंक्शन जिसका डेरिवेटिव cos x है, and that function is sin x plus c. Here students generally commit mistake, they write minus sign. No, cos x किसका डेरिवेटिव है? प्लस साइन का. cos x is derivative of sin x plus any constant. Now d by dx of minus cos x is sin x. Cos x का sin x है, तो minus cos x का sin x. So to find the integral of sin x with respect to x will mean all those function whose derivative is sin x. तो sin x किसका डेरिवेटिव है? माइनस cos x. माइनस cos x को डिफरेंशिएट, यहाँ प्लस नहीं लिखना है. If you differentiate minus cos x, you will get sin x, and minus cos x plus any constant. Then d by dx of tan x is known to us, is sec square x. So integral of sec square x with respect to x will be of course tan x plus c. sec square x इसका डेरिवेटिव है tan x plus any constant का. d by dx of minus cot x, because cot x का cosec स्क्वायर माइनस cosec स्क्वायर होगा, तो माइनस cot x का डेरिवेटिव इज cosec स्क्वायर x. तो cosec स्क्वायर x का इंटीग्रेशन इज माइनस cot x एंड ऑफ कोर्स प्लस c भी लिखेंगे तो यही डेरिवेटिव आएगा. तो cosec स्क्वायर x किसका डेरिवेटिव है? माइनस cot x प्लस c का. नाउ नेक्स्ट d by dx of secant x or sec x is sec x tan x. So the corresponding integration is of sec x tan x. sec x tan x का इंटीग्रेशन का मीनिंग, sec x tan x किसका डेरिवेटिव है? sec x का secant x plus c का. d by dx of minus cosecant x is cosec x cot x. तो cosec x cot x का हमें इंटीग्रेशन लिखना है. cosec x cot x इंटीग्रेशन मीन्स दैट फंक्शन हुज डेरिवेटिव इज दिस. ये किसका डेरिवेटिव है? माइनस cosec x plus c का. देन वी नो d by dx of sin inverse x is 1 upon root 1 minus x square. Of course there is some domain for this, I am not writing that. Mod x should be less than 1. So 1 upon root 1 minus x square का इंटीग्रेशन वी हैव टू फाइंड मीन्स दैट फंक्शन हुज डेरिवेटिव इज दिस, ये किसका डेरिवेटिव है, साइन इनवर्स x एंड ऑफ कोर्स प्लस c, d by dx of cos inverse x, d by dx of cos inverse x is minus 1 upon root 1 minus x square. So we can say minus 1 upon root 1 minus x square is cos inverse x plus c. और अगर मैं माइनस को यहाँ कर दूं, यहाँ प्लस कर दूं, तो मैं यहाँ प्लस लगा दूंगा, तो वी कैन मॉडिफाई अवर फॉर्मूला, वी विल से 1 अपॉन दिस इज माइनस कॉस इनवर्स एक्स प्लस सी। तो इसका ये भी डेरिव इंटीग्रेशन है, ये भी इंटीग्रेशन है, और ये दोनों सेम आएंगे, इनमें कांस्टेंट का फर्क है। अगर इसमें पाई बाय 2 माइनस साइन इनवर्स एक्स लिखूंगा तो वेरिएबल पार्ट विल मैच। सो वेन एवर वी इंटीग्रेट बाई टू डिफरेंट मेथड, वेरिएबल पार्ट विल मैच, constant may differ. Then d by dx of tan inverse x is 1 upon 1 plus x square. So we can say 1 upon 1 plus x square by integration is, here you write dx with respect to x, इसके बिना मीनिंग नहीं होगा, tan inverse x plus c. Then d by dx of माइनस कॉट इनवर्स एक्स भी यही होगा, कॉट इनवर्स का माइनस 1 अपॉन 1 प्लस एक्स स्क्वायर, तो माइनस कॉट इनवर्स का ये, तो d by integral of 1 plus 1 upon 1 plus x square with respect to x is minus cot inverse x plus c. अब इसको पाई बाई 2 माइनस कॉट इनवर्स लिखेंगे तो माइनस कॉट इनवर्स मैच हो जाएगा, पाई बाई 2 एक्स्ट्रा आ जाएगा। नेक्स्ट d by dx of sec inverse x 1 upon x root x square minus 1. So we can say integral of 1 upon x root x square minus 1 dx is sec inverse x plus c. अब माइनस कॉसेक इनवर्स x का भी यही डेरिवेटिव होगा, d by dx ऑफ माइनस कॉसेक इनवर्स x, कॉसेक इनवर्स x लिखता तो इसका माइनस हो जाता 1 अपॉन दिस, तो आई कैन से 1 अपॉन x रूट x स्क्वायर माइनस 1 का इंटीग्रेशन विद रेस्पेक्ट टू x इज माइनस cosec inverse x plus c also. Then next e raised to power x का डेरिवेटिव e raised to power x, तो इंटीग्रल ऑफ e की पावर x विद रिस्पेक्ट टू x मींस दैट फंक्शन उस डेरिवेटिव इज ex, तो ex किसका डेरिवेटिव है, ex प्लस c का। बट इफ इट इज a की पावर x, तो a की पावर x का डेरिवेटिव a की पावर x नहीं होता, a की पावर x log a होता है। सो इफ आई डिवाइड हेयर बाय log a आई विल गेट a की पावर x, तो a की पावर x किसका इंटीग्रेशन है, a की पावर x log a and of course plus any constant. Now these derivative integration formula, these formula for integration we have written directly by derivative fact. Let us write few more formulas. Integral of tan x. Tan x is the derivative of log mod sec x. This we will prove later on, or minus log mod cos x plus c. Cot x log sin x का डेरिवेटिव है, log mod sin x का, देन इंटीग्रल ऑफ sec x, sec x, अब इसको डिफरेंशिएशन करके देखेंगे, यू विल गेट sec x log mod sec x प्लस tan x प्लस c और log tan pi by 4 plus x by 2 mod, of course, plus c. Cosec x dx log mod cosec x minus cot x plus c log mod 10x by 2 plus c. And one important, this we have missed out earlier, 1 by x integral is log mod x plus c. So initially we'll do these 21 formulas, we'll do integration based on this 21 formula, then we'll do some more methods of integration. So in the next class, we'll continue with the process of finding the differentiation.